We're back for day 3, and I want to welcome everyone to kick off this third day of the Materials Research Data Alliance annual meeting. I'm David Elbert from Johns Hopkins, if you haven't figured that out by now, and here representing the MaRDA Governing Council. But I'm really pleased to introduce Ale Strachan to take over running the day. Ale is also on the MaRDA Council and has been here since the beginning, and he's really done a great job putting together a terrific day for us. I'm going to share for you for 1 second before I do that, the agenda for the day. Take over this screen share. And you should be seeing the website agenda for the day, and you'll see that we have both fair data and autonomous experimentation represented today. We're going to start with a session that Ale will introduce and hand off on fair data reports. These are working groups from MaRDA that have been doing a lot of really interesting work associated with the Martian Award. And then a really interesting panel in the second part of the day on autonomous experimentation in a variety of I highlighted the wrong thing, there we go, in a variety of different settings with a great panel discussion. And so we've got room for discussion in the shared docs on both of those. But without further ado, then, let me introduce Ale from Purdue University. I guess we were all joking about his branded cap enough that we know that. Ale Strachan, please take it away.
Well, thanks everyone. Dave actually stole my thunder. Okay, he mentioned everything I wanted to do in terms of introductions. So Sergei and I will run the 2 sessions, and he's going to start with session 5, and I'll moderate the second session. So Sergei, take it away.
Thank you, Ale. So welcome to the session 5 of the MaRDA meeting. So my name is Sergei Kalinin. I'm a professor at the University of Tennessee, Knoxville. And many of you know, based on my fact that I spent 20 years at Oak Ridge prior to that. So I'm happy to introduce this session combining the summaries of the working group on the laboratory information systems, FAIR train, and FAIR models. So this work has been funded by the FAIR OS network, or Material Research Coordination Network, by NSF as the part of the Martian Award. And without further ado, I would like to introduce the first speaker of the session, Professor Eric Stach of University of Pennsylvania. Eric?
Thank you for the opportunity to report out on the work of this working group. I'm going to start off by saying that I have attended a very small amount of this meeting. Unfortunately, the world's in a very dynamic place, and I run a number of centers that are NSF funded, and I'm kind of dealing with a lot of difficulty at the moment. So hopefully I'll be able to provide something that's at least valuable for this. I have to lead because Josh was involved with this. We have to start off with the very important NIST disclaimer, which I'm not going to spend any time on, but at least it's been shown. These are Josh's opinions and not NIST's. So let me describe to you what this was about. As noted, we were part of this Markin, or however you probably want to say it, Martian network. The idea of this was that we were organized to bring together a group of people who could talk about laboratory information management systems as ways of helping get towards fair data goals. This group comprises of folks from academia as well as industry, and importantly, some important industry partners involved to help kind of frame the discussion. The primary aim of this was to make recommendations to facilitate how people might incorporate these laboratory information management systems into their processes in an effort to streamline the ability to capture data that's properly labeled and has good provenance and the like. So just to define laboratory information management systems, right, their idea is to make sure that they support collaboration, scientific integrity, and transfer of knowledge over time, with the hope of empowering research communities to establish common tools to provide access to laboratory data resources. And so looking at this is basically the outcome of a prior NIST publication or technical note, and some of the things that they can be involved with is to make sure that you have good workflow management, that you connect to data repositories, that they facilitate the creation of data products, as well as provide an organization for future data queries around curated data. So this working goal was established with several working groups established several goals. The idea was to document best practices for recording data in research and engineering, foster awareness regarding recognized schemas used in laboratory information management systems, identify any key gaps in existing schemas and metadata recording methods in our current research practices, but most importantly, also to document and disseminate how LIMS can benefit individuals, institutions, and the community as a whole. So one of the key outcomes of this entire process, as I'll show at the very end, is that working with the other working group on microscopy data, we have we are in second review, and I'm sure it'll be any moment now, a paper that will go into the Materials Research Society bulletin, kind of describing the outcome of these groups so that people can understand what we've learned. So the idea was to talk and deliver documentation of the various capabilities required for implementation of a LIMS. In other words, for people who are in a position where they may be a PI or a manager of a laboratory, they might want to do this, but they need to have some sense as to what's needed. And that also allows us to talk about delivering information about the value of doing this as well as the associated costs, right? If I sit in my role as the director of the Singh Center, I'm the one, going and footing the bill for this. So I need to know how much it costs to, generate the data system and implement the different laboratory information management system portions. I need to be convinced with that hat, why to do this and how it benefits. And also there's costs associated with the implementation for these sorts of activities by people, training on to new things. We need to show them that they're worth doing. We also wanted to review, recognize metadata practices and make sure that we provide references and links to them so that people could see how that is done. And then again, develop a publication to disseminate to the community. We decided on our first meeting to kind of break this up into 3 focus areas so that we could, quite frankly, divide the work, but also think about how to implement these in a logical way. First of all, we focused on the values that you get as an organization for in introducing one of these laboratory information management systems, and also the costs associated with that. We also wanted to think about what capabilities might be in place prior to inserting this into your workflow. And then finally, kind of helping people think about what sort of metadata they should be collecting. So the way that we did this is we had a group of the larger group, we broke into subgroups. We had occasional, maybe monthly meetings for a while. And then at the end, we collected those, both Joshua and I, and frankly, largely Joshua, collected these together to kind of prepare this presentation, which was given to the spring MRS meeting in 2024 as an outcome of this and as a way to solicit feedback. So this is how we did this. I don't think there's any deep knowledge here, but I'm just making sure that everyone recognizes this was a pretty deliberate practice, founded meetings. We had a separate working group meeting with instrument vendors to get their feedback. We had a set of draft recommendations. We reported those out at the spring MRS meeting as well as through other venues to gather additional feedback. And then again, working with the microscopy group, published a paper on this. I'll go through maybe quickly the costs and benefits, the implementation plans, the capabilities and other benefits from doing this. One of the key points is that we, again, use this graphic as a way to describe how this is a beneficial process, right? It allows you to have ways of integrating your data in a systematic fashion and handle your data. It allows you to potentially integrate future autonomous methods, which I think you'll learn about later today while I'm teaching laboratory, and also can help you facilitate ways to interact with external databases and other routines. We're also making sure that the outcomes of a LIMS allows you to have standardized procedures, results, processes, metadata, and also easy ways to export the data to repositories and databases. We kind of went through the costs. How do we go through the costs? I went through my own laboratory and figured out what it might cost for us to take and implement this on the low end on top of an existing NIST platform, NEMO. That was around $30K versus programming time. But if you need to also add storage in, that may be an additional cost. And then you also have to think about the differences between the one-time cost of getting things going as well as ongoing costs for maintenance or future upgrades to storage. We identify benefits as being increased reliability and reproducibility in the data, makes the compliance with fair data principles easier for everyone accessing instrumentation in the laboratory, and also has the potential for future utilization in automated data analysis and eventually autonomous experimentation. We talked a little bit and defined in the paper what we consider to be kind of prerequisites. You need to have a clear sense of why you're doing what you're doing. You need to have a team of people that are representative of the stakeholders. You need to have an understanding of what the existing workflows and practices may be, as well as an inventory of the equipment, instruments, and software that you might want to put this on. It's important to have data migration bucket plans in order to make sure that you're integrating those with the new LIMS system, plans for user training and support, and plans for ongoing maintenance and system updates. So you can see that this is not a small thing to be doing. And I guess my own personal experience is that as a result of working through all this, I have, from the top down in my own laboratory, begun to implement the Nexus LIMS, which is the platform that Joshua's developed at NIST, on a small subset of laboratory equipment in order to kind of shake it down with the intention of expanding it to the rest of the Nanotechnology Center with time. There's a wide variety of capabilities that you might want to have your laboratory information management system take care of. This is here a list of these. Again, if you're interested, I'm trying to make sure I don't take too much time. Interested, you can find this all in the paper, but they're the things you might expect, persistent identifiers, be searchable, be interoperable, the things that are necessary to comply with the fair data principles. We also want to make sure we understood who was being involved in this, right? The roles of the different people involved and how they needed to be working to make this all happen, from the individual researcher to the facility and IT managers, importantly, instrument vendors and their ability to have data that's accessible through workflows and metadata that are not proprietary. We talk a little bit about how to go through the planning process, the generation of the appropriate LIMS system, and then working on how to get the right integration with data and instruments. This is, again, something that comes out of a NIST report from Robert Hanisch. So mostly referencing this as the way to think about the roles. We would recommend that what people do is provide a series of checklists or blueprints for a group, department, or organization, and otherwise try to think about what are the things that work for your particular situation. And then we're hoping that we've been providing with this a things that you should have or do to make it accessible through this report out that we've done. We also made sure to identify some relevant schema about what metadata you might collect. We examined a number of existing ones, noting that there's no need to reinvent additional, standards or processes if they already exist, and instead to adapt those that are working and known to the community. So that's part of what we put forward in this working group was here's some that people are using and seem to be robust and helpful. And then we came up with a set of additional recommendations on ways of thinking about the data, what to capture, how to organize it, and then where to use existing community standards for different types of things like instruments, samples, and identification of people and organizations. So that's kind of the outcome of the working group. If you're interested, we had a website that you can scan here, but I think the most important thing is if you are interested, we have a paper we wrote up working with the microscopy working group that is, I was really hoping it would be published by today, but it seems like it's still not quite there. But it's in a second review, which should be no problem, and should be coming to an MRS bulletin near you. So with that, I think I took the appropriate amount of time, and I'll answer any questions to the best of my ability.
Thank you, Eric. So we have time for a few questions. So either please feel free to raise the hand or just to drop the question in the chat.
Right. Well, I guess I gave a command
Eric,
performance. Yeah, go ahead.
Eric,
Yeah.
so how do you handle, what are your thoughts, what you guys have been thinking? Often the data that you collect raw data, and this raw data is post-processed and analyzed and regurgitated in different forms. And of course, you do that using models, and actually the model and how you analyze your data actually matters, right?
Yeah.
So is that part of the documentation and part of the what's recorded as fair data?
With this working group, we were mostly focused on laboratory information management, meaning trying to understand how to do a good job of imposing appropriate information about samples, instruments, conditions, the state of instruments on top of the data that's collected. You know, your comments would be how do you go through and continue to document the different manipulation stages thereafter? And at this point, this particular way of looking at it was more focused on just making sure that the data had a good set of backup about what processes were involved, as opposed to, you know, I think we all know that in an ideal world, right, with the fair data schemata, you know, you would be able to read a paper, download the data, and have underneath that, you know, every bit of manipulation that happened to it, so you could see how that was done to check for reproducibility and for accuracy. But really, this was more focused on how do we at least start off by providing, and you might even say forcing users of tools to provide some bare minimum of information that allows the data to have more provenance.
Thank you.
So thank you very much, Eric, for the presentation. So I see that there are multiple raised hands and a few questions in the chat. So that being said, let's stick to the time, and that's why we have a panel, right?
I'll look at the chat and try to go through anything there. I am going to apologize at 1:45. I got to go teach class, so I was able to just barely fit this in.
So, and then we'll have the panels that can cover many of these issues. Thank you very much, Eric. And the next talk will be presented by Olga Wodo from Buffalo, and she will talk about the fair train. Again, Martian support from NSF is acknowledged.
So thank you for giving me opportunity to talk about the report on fair train. It's a part of the Martian NSF Award. And I would like to also give a credit to Brian Schuster from University of Texas and his PhD student, very talented PhD student, Erwin Cesares, who also helped us down the lane. What I'm reporting on today is a workshop that is maybe on the other spectrum of the topic that Eric just gave us. We organized workshop for mostly undergraduate and graduate students in Texas, El Paso, where we took this example of tensile testing and as a vehicle to introduce programming in Python, but also data management tools and some aspect of data science. We had 60 attendees from different corners of engineering. Those were mostly second and third year undergraduate students, but also graduate students. We also had few faculty who were interested in learning more about data processing or extracting information from raw data. So what was the goal of the workshop? It was, first of all, it was a 4-day long workshop. It was 1 week before a spring semester started at University of Texas. And we used the tensile testing, so basically the very standard characterization tool that most engineering students will be exposed to during their education, to analyze it and extract few characteristics points from this raw data. Students perform their own characterization. We didn't give them raw data. We said, okay, you have a sample, you measure the sample, you extract information that will be needed for you, you will run the characterization, and you will analyze it during the workshops, save the results using dictionaries, and then share it with others. It's a beautiful example of experiential learning where they learn through action or discovery. They get sufficient programming syntax to perform the analysis. We do not expect them to go through all chapters of any textbook on the programming. They learn as we go. They learn data structures in terms of array, list, and dictionaries that they later on use to save the data they extracted. And we also introduce them into linear regression as a way of extracting Young's modules from the curve. And finally, they also got exposed to data management systems, very basic stuff like how do you define your JSON schema? Why do you should even care about it? What are the repositories you could consider? And overall exposing them to FAIR principle. At the beginning of workshop, we ask students, so like, do you even know what FAIR is? And the honest answer is barely anyone knew what FAIR is. So I guess in this sense, we achieved, it was a success because we exposed them to those topics. So what was the setup? There was assumption that students have no programming experience, although in the survey, they all reported that they had some exposure. They didn't have a high confidence in terms of their programming skills. We just ensured that they have some engineering background so that they are familiar with material properties. So each day would meet, and in the morning they would get some short lecture, but most of the time they would spend in the computer lab. We had students assisting attendees, so if they get stuck with something, they had some questions, there was someone to help them. In terms of like tensile testing, we had two machines, Silotech and ADMET. I think it was day 2 where students would start going to the testing laboratory and checking and testing those samples. Samples were prepared for them, so this is like where we simplify the problem. If someone would be interested in merging this workshop also with 3D printing, this is a great opportunity also to ask students to print their own parts. And the raw data downloaded from the characterization tool was also processed for students, so they just got like a displacement, low displacement curve. So many things were simplified, but they were still asked to measure their samples, and samples varied in terms of dimensions. So there was like a part of the work they needed to do, and some part was outsourced for them. Thinking about the outcome from this exercise, we got roughly 100 samples that students tested on those two machines. They are color-coded here, so this is stress-strain curve. So each student got access. So even though they measured 1 or 2 samples, they all got access to all the measurements. Through the workshop, they were asked to extract few characteristics points. So the simplest one was just to take the maximum value of the stress. This is ultimate tensile stress. But like this is the great opportunity to increase the granularity or like how complicated the assignment can be in terms of property extraction. At the end, all students got to plot the histogram of properties extracted by all other attendees, and they could see how large variance the measurement can have. We had the discussion about why it's so large, but I think just showing students that basically there are many things that may require fine-tuning was also great experience. In terms of what happened between the idea and the outcome, on day 1, they got overview of methodology for tensile testing. So some of them didn't have it, so it was good to introduce certain terms. And they got this classic pen example. Brian insisted that I put it here because it's such an important thing, though. So they learned the concept, mechanical, the engineering concept, and then they needed to translate it and extract those properties on the printouts and make sure that they understand things correctly. And in the afternoon, they got introduced into Python, very simple setup. Most of the things were adapted from a book, Automate the Boring Stuff with Python. On day 2, they started making their own experiments. They plotted the raw data. They used this pen and paper example to validate or to debug their own code. And we start looking into linear regression and extracting the slope from the data. Day 3, this is where we increase the complexity of the assignments. We ask them to write functions that would extract those properties. We introduce them into data structure. We ask them to create a dictionary with extracted properties and share with others. So at the end of the day 3, the expectation was, and it did happen, that the histogram, the students and attendees generated this histogram. Some of students were able, or attendees were able to go further and extract more complex properties, but this is where we were at day 3. And on day 4, we started talking about FAIR principles, sharing the data. Why sharing 2 websites is not a good idea, because later on you need to do some form of web scraping. We talk about the repositories, persistent identifiers, and metadata in general, with a Dublin core as a good example, or already adopted by many places, example of metadata. It's such a simple metadata with a very, very good history that I feel like it resonated well with students or attendees. Something that resonated well was also JSON schema, how easy it is to define it, at least for simple data as the tensile testing. I feel like if we can reach with FAIR or data annotation till this point, and we can show the value of the defining those schemas and validating your data against schema, I think this is already like relatively low-hanging fruit that the community can benefit at all. We close the day 4 with more advanced data representation topics. We talk about ontologies, RDFs, and also different ways of representing knowledge. This is where Erwin, the PhD student, shared his experience with defining and using ontology for his own research. I took a risk and did also live demonstration of how can you use large language model to help students extract data from extract properties from the data. So basically we repeated the exercise over the last 3 days. And what you need to do when you do your prompting, how do you check? It was like a good exercise to show how advances in large language model help us to improve our performance in terms of coding. We close the day 4 with an example of machine learning. After all, once we do our data annotation, data integration, we'd like to use it for some tasks. So I gave overview of example study that could be done using this type of data for cellular solids, so that they can see where this analysis can go. In terms of next steps we are planning, as of now we are refining the workshop materials. We have a good collection of notebooks, lectures, also G-code, simple examples, schemas, validators that we'll share with the community. I'm working with a student to develop maybe some scripts for REST API in terms of upload and download, let's say into Zenodo. We plan on publishing the paper possibly in the next few months. And at the end, it's all about repeat and iterate. So where we can take this workshop and try it again. And maybe adopt this approach for other characterization methods, maybe polymer rheology or multimodal characterization if we have a given material and would like to test it. I think something where we could improve, we could start with a larger example towards machine learning task rather than testing similar material with similar properties. We would like to reuse the data in other iterations of this workshop, possibly also talk about FAIR models, because the code they develop can also be used for some training in terms of FAIR models. So this is where I think I will stop to give you a sense of where we are as of now.
Fantastic talk. Thank you very much, Olga. And
Thank
the
you.
idea of combining hands-on stuff and learning Python, that seems to be really the way of the future.
Right.
Any questions?
Yeah, sure. I think Richard had one in the chat, and I had one as well, but actually I'll read Richard's. It seems a lot of time was spent on the Python training. Was that training successful in retrospect, or were there lessons could be learned on how to balance programming and actual data manipulation? And speaks to his experience where everything has a unique balance.
Yes, and I think so when I was thinking about this as a starting point for maybe other activities, I came up with this table where I feel like we are touching on a few things here. So here we focus mostly on the first two aspects, so basically Python and characterization. Mostly because the way Brian had his vision for this exercise was focused around characterization and Python. So that's what he already did over the last few years in his teaching practices. So we started here. But I feel like this can be a great vehicle to also talk about the data science or like design of experiment. And thinking even or the way maybe I will use this exercises. This is what I teach in quantitative structure property relationship in my experience. So I'd like to link maybe the cellular solid design with this data management system and maybe and limit the Python exposure. Yes, this year this workshop was centered around Python, but it doesn't have to be. I feel like so many directions it can take on, and this is a good basis for other things to talk about.
But even the data science side can be in Python. I mean, it could be in R or whatever, but
yes,
it doesn't matter too much. But it's a difference between programming versus analyzing and doing things. But
I feel like this is where like you actually the students have like a task, right? They want to analyze their data, and as we were like talking with attendees during the workshop, they said, okay, I came here because I want to analyze my own data. I have a task. I don't feel confident with programming. So they came and they wanted to improve their confidence in terms of programming. So it was good to see how they came with their own problems. And at the end, many of them, not all, because like nobody's successful in terms of 100%, but many of them said, yes, this helped me a lot.
I think it may be super useful to see how the fact that they know how to use Python will factor in the experimental planning and learning with equipment. So opening this type of feedback loops is really highly exciting and absolutely impossible if you deal with the pre-acquired data sets. So it's really a great exercise.
Or even robots, right? So even one takes this takes a simple like 3D printer, like how can we like design another like workshop where they would be introduced to robotics? I feel like this is like the path where we should at least have ambition to go.
Thank you very much, Olga. And it's time to move on. And the next speaker is none other than Strachan. Ele, you have the floor.
So, yeah, thank you. So I'm going to tell you about FAIR models and FAIR workshops. So if you ask any 12-year-old to find a song, in a few seconds, they're going to play the song for you. And if you ask a PhD student after years of training to reproduce a research result, they'll take months, okay, often. And so I think it may be time, and this group is the right group to do this, is to maybe rethink how we share the product of our research. And I think the analogy between publications and music is a valid one. We more or less globally publish the same number of songs every year than we write papers, okay? So if you go back to the first scientific paper, it's more or less recognized that the first paper was in 1666 in the Philosophical Transactions, and you can actually go and read the paper. So back then, if you wanted to listen to music, new music, you had to be friends with the royal family and be invited to a fancy place where the musicians will play music for you. So it's restricted to a few people. Almost 2 centuries later, you can find a paper from the 1850s, and we have gramophones, right? So at home, you could play music. You didn't have to go to the palace. 1900s, the Physical Review started publishing papers here in the US, and we had radio, so you could listen to new music from home in the early 1900s. This is 1980. This is a well-known paper about molecular dynamics. This is some of my colleagues. And some of us are old enough that we walked with cassette tapes and listened to music that way. And of course, now we all listen to music using streaming devices. And here's a recent paper. Since the 1600s, our publications haven't evolved. The only innovation is that now we use color in the titles of the publications. Okay, so maybe it's time to rethink how we share our product, the product of our research, and that's the goal of our RCN. Okay, you have heard several times about Martian. It's a group of people, and we're trying to push our community to think beyond the paper. About one of them, we don't have FAIR trained twice. That's just my typo there. But what I'm going to talk about is work that Ben Blaiszik and my group have been doing in terms of FAIR models. Okay, so when we think about FAIR, we often think about data, okay, experimental data, computational data, but data workflows also fall in the same category. And that's really what the effort that Ben and I are leading, it's all about. And so this is maybe a motivation, maybe you know these papers, maybe you don't, but the bottom line is the Git repositories and Jupyter notebooks are great, okay? And people are sharing their notebooks, and that's terrific. But that's not enough. If you look at several large-scale studies, when you get notebooks from a Git repository, even those that are highly rated, the majority of them are not executable. This last effort that I'm highlighting here, they try to use LLMs to try to fix the environment, files, and whatnot, and they could get a few more of these workflows running, but the majority of them simply don't work, okay, even after you try to fix them a little bit. So what can we do to improve this? And definitely LLMs, as you can see in this study, play a big role. Ben Blaiszik has been leading these very exciting hackathons where you bring together people and they explore the power of LLMs for material science and chemistry. And each of the groups, they work on different projects. This last summer, they had the second installment. It was virtual and in person, so it was hybrid. You can see the locations here on the map, and they had 3 times more participants. Lectures from industry, very exciting work. They're working on a paper, so stay tuned. And they published the findings of last year, the 2023 hackathon, on a paper, in a paper that I would recommend that you all take a look, okay? And so here's the paper, write it down. And they have all sorts of examples of how you can use LLMs to do workflows in material science and chemistry. And the fact that you use an LLM as opposed to manual steps done by a student actually helps with reproducibility, okay? So this is just one of the projects that they highlighted in the publication that I would encourage you to look at. At Purdue, we had an in-person workshop where we introduced students to a bunch of different workflow managers and workflow systems, okay? We had people from Switzerland. They introduced AIDA, which allows you to do very complex workflows, several steps, with checkpointing, saving the data in a way that you can recover it. you can, those workflows, end-to-end workflows from inputs to outputs can be shared across labs, use HPC resources. We also had a presentation from Jarvis, about Jarvis from Kamal, and Garden and the Foundry Machine Learning from KJ. And these are general repositories and workflow managers for material science. And we had a very interesting talk from Emory University on autosolvate. So this is using DFT calculations for solvation, which also involve multiple steps. So what Fang Liu did is put these end-to-end workflows that people can use for reproducibility, okay, where all the steps are documented, all the intermediate steps are documented. An important aspect, and we did one on NanoHub that I'll mention in a second. An important aspect is these workshops, all of these were hands-on, okay? So the almost 50 participants actually run simulations during the workshop. It wasn't just a bunch of PowerPoints, okay? Everyone worked their own workflows, published workflows, shared their material. If you're interested in these, all of the lectures are recorded, all the hands-on activities are recorded, and the tools are available online. So you can go there and learn what everyone did. With these online presentations, the online version, we reached double the number of learners that actually were able to come to Purdue, right? So I think sharing these materials broadly is an important way to spread the word. So let me just take the last few minutes to discuss how I think we can improve on simply sharing a notebook on a Git repository, okay? So think about what the work that we do is. Eric Stach was talking about generating experimental data, okay? And so you generate data, but of course, when you publish a paper, you don't publish just the raw data, right? You analyze the data. So there's a workflow that turns that experimental raw data into the intuition, the materials properties, the phenomena that you want to discuss. On the computational side, either physics-based simulations or machine learning, it's very similar. You have inputs, you have a complex, multi-step, often, workflow, and then outputs, okay? And so we all share these notebooks that do this work, but as I mentioned, 70% of those notebooks don't work. And they don't work because of changes in versions, environment variables, and whatnot. So one of the things we've been doing at NanoHub is, if you have one of these notebooks, you can come to NanoHub and actually publish your notebook. And what I mean publish is a real publication with a DOI that's actually indexed by Web of Science, so you can get citations. And all we ask that you do is, you have your notebook, you have to formally declare the inputs and the outputs, okay? So you have to say, okay, these are input variables, these are the ranges, and this is the metadata associated with each of the inputs, and doing the same thing for all the outputs. And then you just, we publish it like you publish a paper. The advantage is, I mentioned, you have DOIs. You can query through an API the inputs and the outputs. So you can ask the question, is there a workflow that takes this type of data and will produce this type of result? So I don't have to reinvent the wheel, okay? We have hundreds of these workflows already published. The other thing that we do is we containerize it. So that environment in which you created the notebook is containerized. So that notebook, once it's published, will always run using the exact same environment. We have tools in NanoHub that are 15 years old that still run in an environment that's that old, okay? And unless we can't maintain those environments for security reasons, those will be permanent, okay, for decades, as opposed to maybe weeks, like we do today. And so the workshop, they're actually reproducible. And the last important thing that I want to highlight is once you have a workflow published, it can be executed on demand, okay? Anyone can access these workflows and say, hey, here's my input data, run the workflow and tell me what the outputs are. And again, this could be analyzing experimental data or a computational workflow. So these on-demand execution of the workflows, they can be through an optimization algorithm, through AI, through lots of different environments that actually call the simulation as a service. This is an example of an active learning loop that used a molecular dynamics workflow that calculates the melting temperature of materials. And an undergrad student used this pre-sophisticated set of simulations to predict a high entropy alloy with the highest melting temperature. Okay, an undergrad student, and they didn't need to worry about all the computational aspects, setting up the simulations, where does it run, all that is transparent. So the student could focus on the machine learning and the domain problem. Every time anyone runs one of these workflows, the inputs and the outputs are automatically stored in a database, and the database itself is fair. So the workflows are fair, and the data that they generate from the community are also fair. And so by the time you finish your paper, all the data is published, the workflow is reproducible, and anyone can actually follow up on your work. So we just wrote a paper that was submitted very recently. Another undergrad student followed up on the work that we first did and learned from all the data that the first student had generated, right? So he showed that he could come to the solution much faster than the first active learning paper because he had access not just to the tool, but to all the data that had been generated. And I'll stop here and happy to answer any questions if there's time or answer those in the panel. Thank you very much.
Thank you very much, Ele. So I think in the interest of staying on time, we have to defer the questions to the panel, but the examples that you made are definitely very inspiring. So at this point, I would like to pass I know it's not the floor, it's a screen and mouse, to Cate Brinson of Duke University. So all yours, Cate.
So thank you. Really inspiring presentations by everybody. It's been great working with everyone as well. So I have, so instead of presenting what we have already done, this is more of a soft launch of what we hope to do. So, and this is on trusted repositories, but it again is a part of this FAIR OS RCN called Martian that we've been discussing. And the piece I've been involved with has been a collaboration between Duke and Northwestern, and that's why Northwestern's name is here. And the reason there's a question mark here is because I'm not sure who from Northwestern will be involved in the trusted repository. So I didn't want to commit somebody without having already sorted it out with them. So this is my view of this Martian network that we've been discussing. And my piece of it that I'll talk about here is FAIR data. You just heard Ale talking about FAIR models, and FAIR train was Olga. And then Eric at the beginning also talked about FAIR data in the context of the LEMS data. And so the priority areas that we had for our data threat, one of them was the electron microscopy that was just talked about. Looks like, okay, I see. That was just talked about, and there were two working groups within microscopy data, one for LIMS and one for the microscopy metadata that was formed. They had meetings, as Eric described, came up ultimately with recommendations that are published or almost published. The second priority area was trusted repositories, and this is starting now, right, with our soft launch today. And so this is, as Eric was indicating, these are the two working groups for the microscopy data. I think Eric talked mostly about this one on limbs. There was a companion group on microscopy, and then there was a joint paper that was published. And so this is that paper that is still to appear, as Eric said. And then I just wanted to point out that we also had a prequel paper that was also published in MRS Bulletin last year. And this was talking about community action on fair data. And if I can just show one of our roadmap figure from that, you'll see that this roadmap includes a lot of the things that we've been talking about that we're doing actually in Martian, including the models, the fair models like Ale was talking about, and the education part, the fair train like Olga was talking about. And then also a piece of this is trustworthy repositories, which is where this next working group that we will be forming will be coming from. So I have a couple of slides here to just sort of set this up, and then I'd love to take more questions in the panel discussion and also take your ideas. So there's a Google Doc where you can type things and it'll be preserved. And so if you have ideas about trusted repositories, please put them there and we'll be able to review them. So one question is, why can we just have a Google for materials data? And if you type, just for fun, I type materials data into Google, and then I get this result here, and we can see that materials data facility is there, and that's actually a materials data repository, but we get a lot of other things that are not materials data. So that's a little bit silly. So, but we could also, of course, go to Google Scholar, and then in Google Scholar, we could actually give it a specific query. And so I gave it a very specific query about glass transition of a particular type of nanocomposite. And then we all know what happens if you put that in Google Scholar, you just get a list that is, in this case, 50,000 long of papers that I could click on and maybe get a PDF if my library has access to it, right? And then you might say, well, that's so 2021 Google Scholar. Let's go to ChatGPT. Surely ChatGPT can tell us stuff today, or one of its friendly neighbors in the landscape. And so you can give it the same kind of a query. And you do actually get a really nice answer here. This is, it's thoughtful. It is factually correct as far as I can tell. But it's really not useful. It's not giving me the data. So it's not telling me what is the largest, and it's not giving me a compilation of here's the 500 samples that have been tested, or the 1,000 samples that have been tested, and what the values of this property are for those systems, and what the composition is for those systems, and what the processing conditions were for those different systems, so that I could tease apart this data, right, and really start to understand it. So this is where we are. So ChatGPT can't help us fully yet, although it can help us in a lot of ways, as a couple of other people have indicated on this panel. And so we're still left again with why do we want trusted materials data repositories? And as I just indicated, we'll be using repositories for different reasons. We may want to promote our work, put our own work out there so others can find it and actually get the data. We may want to benchmark our own work. So I may have done a new computation or measured something in lab, and I want to see where does it stand in the realm of the world of all of the 50,000 hits in Google Scholar that are relevant to that particular work. We may want to just share data generally and be a good citizen and wanting to share our data. We may want to share more locally, just with collaborators. We may be wanting to meet requirements of funding agencies that we're supposed to be sharing our information and making it available. We may just want to find out stuff. We may just be curious and trying to explore, right? We may be wanting to train or fine tune machine learning models. So we might be not wanting to put data out there, but we may be wanting to get a whole bunch of data and try to learn something new based on this data. We might be interested in reproducibility, like Ale was just talking about. So having all of the data appropriately annotated and stored and easily accessible in a trusted repository is one way to do this, right? And there has been progress on materials repositories. And this is I think following on, we're decade plus or two later than the biological community that has many, many databases that are in active use and fully supported. It's really quite impressive. They have a whole ecosystem that is continuously updated and maintained and heavily, heavily used. And on the materials side, we have many, and this is just a smattering. And if you go to this NIST website for the materials resource registry, there are many, many more that are put here, right? So these are just a smattering of places that you can find materials data, but they have all sort of grown up kind of like the Wild West, right? And so what do we know about trusted repositories? So sort of like motherhood and apple pie, we believe that these trusted repositories are a critical step to broad access and open science. We know that repositories require materials vocabularies and metadata standards, like Eric was talking about, and ontologies and data dictionaries. We know that it can define benchmarks and data sets, and that it can provide a place for AI-ready data, right? So this is what we sort of know about what we think trusted repositories might mean. And then the question is, well, why do we need a working group? Well, we need a working group because there's still a lot of things that we don't know, and we need to provide guidance and to explore. There's a lot of questions. One is such as general repositories, such as Zenodo or Figshare, where you can put anything from any field, or do you want domain-specific repositories, like the list of materials repositories I was showing earlier? Do we want to have metadata that's general for materials, or very focused material-specific metadata? Like how do we slice and dice this? How do we propose this to the community? Where do we put our shared vocabularies and schema and ontologies? And I have a little graphic here for BioPortal, which this is a place that we've put the ontology we've created for materials, because there is no such place for materials that I know of that's a one-stop shop. This is really quite impressive. If you go and look in BioPortal, they have over 1,000 actively used biological-based ontologies that are used by many different projects. I see someone put something in the chat. This is great. I'll go check it out later. We want to have questions also about how to promote and incentivize standards. Like what do we, to make something a trusted repository, does it need to use certain standards? Does it need to have its ontology or schema shared in a specific place? Do we need to have certifications like Core Trust Seal? Do we need to have a stamp that's put on any repository that we call a trusted repository? How do we work with journals in the context of these repositories and the data? How do we handle interoperability between different repositories for different purposes, for different materials? And then what about LLMs, right? Surely they can help us. And then I have a little segue or little sidebar here that if you try to manually curate data by having a student or an annotator rigorously read a journal article and try to pull out all of the data and create the sample list and tag all of the metadata and really figure out exactly what was done to every single sample and enter that data into a appropriate template according to the schema and upload it into a system. This could take many hours for just one paper, so for maybe 10 samples, right? If you create an LLM pipeline, and this is something that we have been exploring in my group, you have the potential to do something like 200 samples per minute. So that's about a 3 order of magnitude increase in speed of gathering data from either journal articles or from collections of files or from extractions from LIMS systems, et cetera. So there's a huge potential to have this help us. And so back to the questions for this working group focus. So instead of what about LLMs, I think we say how to leverage LLMs. So this would be the list of things that we want to explore in this working group. And then if you're interested, please let me know. You could put your name in the Google Doc. You could contact me directly. If you have suggestions, other comments, please put them in the docs, raise them in the panel discussion. And the overall plan would be to run this similarly to the microscopy and LIMS working groups. We would launch it sometime later this spring or early summer, have a number of meetings, maybe a couple face-to-face meetings and some working group meetings virtually, get some expert input, make some decisions and some recommendations, and then publish those. And I'd like to go more than just publish and maybe take some very concrete actions out of the working group. So that's my spiel for my soft launch of trusted repositories, and I hope there's some interest in this. Thank you.
Thank you very much, Kate. Any questions, or should we just move to the panel? So both can be done.
Yeah, I don't know how I did for time. I think I'm on time. Yeah.
You did perfect. Cannot be better.
Yeah, I saw some chats flying by, but I couldn't read them in real time.
Yeah, Kate, just like really exciting. I need to talk to you more, given some work that we're doing on ID4 that I think folds into this. But
Great.
just really, yeah, I had to switch computers. Just excellent. Great session. Great session.
Great. Yeah, I'll hit you up for the working group.
Yeah, please do.
Fantastic. Okay, so then let's switch to the panel session. So I would like to ask the panel members to make themselves visible on the screen. And I would, in the interest of time, I would love to be happy to introduce all of them. So currently on the screen, we have Olga, Ale, and Kate. So Kate leads the Advanced Materials Lab in Duke, and with the focus on complex materials and polymer-based systems, focusing on nanostructure polymers, interfacial behavior, structural metamaterials, and of course, AI and data platforms for materials query and design. Ale is a professor at Materials Engineering at Purdue and co-director of NanoHub, so probably one of the oldest, if not the oldest, efforts in the community-wide science, and works on multi-scale materials modeling and materials informatics. Olga leads the Microstructure Informatics Lab at University at Buffalo and develops microstructural representations methods for machine learning models. So covering heterogeneous microstructures, application to energy conversion, and storage devices, and more recently, mycelium-based materials for soil remediation and filters. So these are our panel members.
Sergei,
so the way
I'm here as well. I just am not pinned to the screen yet.
Ben leads a group at the University of Chicago, focusing on building data infrastructure and sharing, publishing, and usage of leverage of data, more software to promote data and model sharing, publishing and usage, and leveraging the AI technology to accelerate research in materials and chemistry. So the way that we are going to run the panel is we'll have some starting questions, kind of to seed the process, and have all the panel members to kind of chime in and share their vision for that. And the best way the panel can proceed, if there will be new questions appearing in the chat, so based on the discussion and based on previous presentations. So my job is, in this case, is all-important job of curation. So figuring out what is the next question. Sounds good? So let's start with the question is, so you reported, all of you have reported a very cool summary of the current working groups. So can you share your experience on what worked well and what can be improved? So the time is developing very fast. So the trajectory of AI tools coming from the Google, Meta, and so on and so forth is very, very steep. So how can we do things better, both on the ML side and on the human interaction side?
I'll start with the easy answer. I think it's easier to work with students and younger folks than with older folks. So I think Olga had similar experience. She organized a little meeting in DC that we participated, a bunch of very excited and active students. And so And we had the same experience here at Purdue. Okay, the students were very excited, very hands-on. They grew up with this technology, and I think that's the place to start. And new maybe researchers, either in academia and industry, national labs are the ones that are going to carry this forward. So I think focusing on those is the way you change, move the community forward.
Yeah, I'll agree with Ale there. I think that, we're all, Ale, you and I are in danger of becoming the older folk, but
I'm not in danger.
we like to work with the younger folk. And I really liked your comment about the workshop that you ran. And I think it's good with our hackathon as well. That we try to make sure that our outreach and events are not really just a bunch of PowerPoint presentations. People are interested in building things and doing things that end up on their CVs and resumes and can build their career. And so having events where you can build things and show that off, I think, is one way that we can, really significantly scale our efforts of outreach and connecting the community.
I think we should also increase incentives for students to work on data management systems, right? Quite often, we focus so much on science that we are trying to answer those big questions, and we tend to maybe minimize the data management aspects of it, right? So if we have a student who is already interested in this type of work, maybe the way we think about it should also change, the way we reward the data management, right? There's a lot of work done in terms of posting data sets as a research product and citing it, right? So going this direction, I'm thinking should also require us to change the way we value the products. Well annotated data sets should be well cited.
I guess the way that you run your example of the tutorial sets there's a precedent for it, right? You can ask students to make the experiment and 2 months later ask them to analyze the results, which can deliver the value of the data management in a very direct form.
Correct. I was actually thinking that as a part of the workshop, students should upload their data to Zenodo, or the REST API that I'm now working with students to develop is basically you download all the data from Zenodo from previous years. It doesn't have to be Zenodo, but another repository, right? So we start the workshop by searching the keyword, download the data from previous years. I don't know, small things like that.
So what was your experience, Cate?
So I'm sorry, I was answering something in the chat. So this specific question is about involving young people, or
about the learning from the current work groups?
Oh, there's a lot to learn from the current working groups. I think they've done things spectacularly. So they've reached out to the community. They've involved the younger generation. They're publishing things, so they're getting out in the world with the articles and MRS, and then the workflow options that Ale was talking about on NanoHub for preserving functionality of these notebooks long term. I think these are all wonderful exemplars.
Fantastic. So David, you have a question?
One thing that came up, this great panel, I love hearing all these reports. One thing that came up specifically with Olga's Fair Train work was what we need to support these things. So instead of going to Zenodo or something, how do we have some place that the students, when they're doing the workshop, the data can go somewhere, and can we make that a public resource? So, part of the dream was, here's a GitHub repo, somebody doing tensile testing in their sophomore level mechanical engineering material science course just can grab it and do it. And we want to grow that. But then where can the data go? And then when that course is taught 2 years from now, the students can compare not only to everybody else's data in the class, but what happened 2 years from now? Or what would be so wrong about comparing a 3D printed dog bone tensile test to something on a stamped piece of metal? That's not something that anyone would normally do, but let students play or do it with a cohort in Germany. And so for me, I'm wondering, for Olga and for the other groups, Ale has a place that he can put things, right? He's got NanoHub kind of in his pocket, but is this something MaRDA should be working on saying, we're going to make this resource available so people can play in this space? Or is it something everybody has to do on their own?
I think maybe piggybacking a little bit on the next session, I'm excited, and we're trying to do take baby steps here at Purdue, where when we teach lab courses, the data we start instrumenting our equipment so that the data is actually automatically stored. And so imagine you teach a course, right? We all do these tensile tests. And so the students, before going to the lab, they analyze or reanalyze the data that has been generated by generations of prior students. And when they go to the lab, they have the experience, they have a question that they want to answer, right? One of the challenges I feel when students go to the lab, which is very important, right? That hands-on experience, is that they're learning solutions to problems they don't have. But if they were able to browse through data, right, and see problems with the prior data, that you can analyze it, right? And when they go to the lab, they have a little bit more curiosity. So I think there's just a lot of things that can be done. And I don't think it's a technical problem, maybe instrumenting a little bit, the experiments a little bit, but we still do at Purdue, the students collect data and they email Excel sheets, right? Come on.
So if I may try to rephrase what I heard, sounds like it goes down to two issues. One is the activation barrier to do that, so how difficult it is to realize it. The second one is the motivation. Why would you want to do that? So in the initial work, when we talk about depositing data, there is no benefit for the person who does it, except there is a benefit for the community, but activation barrier is large. Once we do it in a while, that becomes useful for the community as a whole. And the best way to learn that it's a great thing to do is derive some downstream value from the data someone else created and figuring out what type of difficulties you have if the data repository was created in the non-optimal way. Would you agree?
Yeah, I think so. And I think I'd augment what Ale said. And so I think it's also subversive that when students are doing this all through their education, they think that data sharing and being able to look at other data to see what's going on with their data is the norm. And that's our future. So.
But were you asking, David, should there be a specific place to put this? Like MaRDA gets a little portal on Zenodo or someplace, right? And this is where we put things like Olga's tensile test training set or something specific from Ale's model workflow, and then it points over to the maybe some data, and then it points over to the NanoHub, so they could go there for that particular problem. So get a centralized portal that says these are some test problems that have been vetted, sorted out. There's code, there's data, there's some description of how to do this, so that people could follow along, use it for their classes or their workshops, and then they could also maybe add to that data. But adding to that data, do they just add willy-nilly, or is there some sort of vetting process or approval process?
I think the plan was that we'll have a bunch of GitHub repos, right? In github.com/MaRDA-Alliance that are these types of problems. And Olga's got one. It's not on that particular GitHub organization, right? So people can grab it. So that's the code. That's everything they need to know to run a notebook to do it. But then what database are they're gonna have to stand up a local database? And I'll do it here. I'll host it here. It's not that much data, but we need to know what it looks like. Or do we host it a lot of places? Is it smarter to do it different ways? But I do think that if we want some faculty member to grab this exercise and use it, they shouldn't have to solve all those problems, I guess is what I'm saying.
Yes. So I guess a couple of points. Ale, I know you've got NanoHub, which is great. So one, I want to point out that there's sort of this foundational problem, which Sergei hinted at, which is that data sharing is not really incentivized. So, making sure that we find ways around that, I think, is very important. I think that crosses what Olga, Cate, Ale, all of us are doing, whether that's getting it into the way that people are judged for future grants or for tenure is very important. But also I want to point out that a couple of years ago, we worked with Jonathan Emery at Northwestern to post some standardized electron microscopy images. These are, tens of gigabytes of data that were then used in a class that he ran. We posted that curriculum onto NanoHub. The data was sitting on the materials data facility in Foundry ML. So it's very easy to access, very easy for the students to just grab through a Google Colab. And then it was ported to UChicago and Wisconsin classes as well. So I think, we have a lot of the infrastructure available, whether that's GitHub, NanoHub, materials data facility, Foundry ML. And now we have to really think about some of those deeper social problems almost, right? Where it's like, how do we incentivize people to do things that might take them a little bit more time?
I agree, but Ben, I would be interested in learning the results that you just quoted with the microscopy data. I could take it to the next level. I think it also goes back to the details of metadata of the experiments that we run, right? That's why with Brian, when we are thinking about sharing the data, would like to share everything that someone may need to rerun these experiments. That includes like G-codes, that includes like STLs. We don't need to reinvent the wheel. That's why we are so conscious about what someone would need to rerun it. And only then integrating data makes more sense, right? So we should always think about what is the ultimate goal. I had recently very interesting question with meeting with the people designing ontologies. And the first question they asked me is like, what do you need ontology for? And it was like they ran the whole conversation around the question we are trying to answer, right? With this tool that is like, it may be very complicated very quickly. So I think we should also think, what do we want to, we can solve so many problems, but like, at least from the perspective of the workshop that we run, if we can just integrate data from multiple workshops, I think this would be like such a great thing to do without thinking about the long implications of that, just like a small low-hanging fruits. One step at a time, but also changing the culture. I think that what Ben just said is like, I think we need to change the culture, and it also resonates with yesterday's panel. We need to change the way we work. Like,
I guess the big part of the equation here is the question of the downstream use. So for example, for all the data sources where we learned how to extract the value downstream, for example, thermodynamics, genomics, X-ray, the community-wide repositories emerged and the common standards also emerged. For electron microscopy data, the problem is that generally we don't derive any downstream value from integrating multiple electron microscopy data sets. They're always analyzed individually with the maybe sole exception of the cryo-EM, but cryo-EM feeds into the biological discovery pipelines. So when the people figure out that you can have the electron microscopy data from 100 different experiments and learn more than you can do from 100 experiments individually, we have a case for the data sharing. Until we do that, then the microscopy data is perceived to be the key product of the group, not the knowledge generated from the data augmented by other data sources, but the knowledge generated only for your paper. That's effectively your passport to high-profile publication. And that is a strong disincentivization for the data sharing. So all the communities, this trend start to change only now. And 10 years ago, you can get an interesting social reactions if you suggest data sharing in electron microscopy community.
I think it'd be interesting for this community to think about, is there the equivalent of the H index for data? And how do we measure it? How do we define it? And I think that obviously in academia, that'll have people pay attention. But it's also the fair thing to do, right? Lowercase fair. It is the right thing to do, that if you're going to share and people are going to benefit from good data that you generate, it needs to be attributed. And I think we do a decent job, not great job at, in papers, at citations. Of course, it's the reviewers and the editors that have that responsibility. But with data, we're just beginning, right? We don't even have a way of evaluating and giving credit to data that is being accumulated to generate larger knowledge.
That probably is super important because no matter how things go on, any system requires some form of motivation and recognition of the important contribution. So whether it would be download frequency or the number of stars of GitHub, whatever it is, that's an important thing to think about.
Definitely.
Of course, the problem is that sometimes you don't know what the downstream value of the data eventually is, right? So if you think about the PDB, for example, Helen Berman was putting in 30 years of effort before Google came around and was able to train the models that they're able to train. So it's really unclear at times which data will be useful when.
But I think that that's absolutely normal, right? If we could predict the exact outcomes or value of our actions, there would be no mystery in life, and there would be no life at all to start with. So this is a great discussion, but kind of in the interest of kind of being more exploratory in topics and not only kind of exploitative over one optimum. So one of the important things about this brainstorming is provide a meaningful impact on how scientific community does things. So how do you think the impact of the brainstorming within these working groups can be amplified and shared with the community and kind of transform and changing the ways how we do science? So what are your thoughts on that?
Can you restate the question? Just
Absolutely. So a part of the work that has been done as a part of the working group is find the best way forward, right? On data formats, on how to make the data fair, derive the new ways of training students. So the practical impact depends on how many people are aware about it, right? So we live in the now we live in the environment when the amount of information that comes to us from all directions is somewhat depressing. So there are multiple opinion pieces being published. Obviously, GitHub is open for exploration. You can find pretty much everything. So how can we scale the impact of this brainstorming activity outside of the group of the people who is now on this Zoom call?
I see. So, well, I mean, we've tried to do that a little bit in the publication of papers, right? So the Fair Data group has published or almost published the paper in MRS Bulletin. So that takes it at least to whoever might read that paper. So that's a traditional way of going, is to publish the findings and recommendations. I think Ali in the Fair Models one created these containerized workflows, right, that people can use. And I think Ben has shepherded similar things through MDF, not explicitly as part of this this Martian program, but just in general. So how do we get people more aware of those things? Like how do we? I mean, Olga can only train so many students at a time in one workshop, and similar for Ale, et cetera. So how do we reach more people?
I think, oh, sorry.
I think this
You
is
go
the
ahead, Ale.
challenge. Sorry, Ben, go ahead.
Oh, I was going to say that, Ale talked about our hackathon, and one thing we tried that was a little bit different with that was that the submission process for the projects at the end was actually very purpose-built to also be our external communication process. So everything was essentially built around social media. And at the end of the hackathon, the submissions were essentially researchers submitted judging a video that they posted on social media somewhere. And then we created those into a chain. And in 2023, we actually got over 1 million views on one of them. So just like the idea that you can scale this without actually getting that much more effort from these people, the students put in, an extra paragraph plus a video, which they would have had to submit to us anyway. But just because we did it through social media, we ended up getting that wide reach.
And social media, you refer to Twitter and LinkedIn, right? So
We told them they could
Facebook.
post on anything that was open. So some used Loom, some used LinkedIn, some used X or Twitter, some used YouTube. It could just be anywhere that was open.
No TikTok
And you said you
submission?
put them into a chain. Where did the chain go?
Yeah,
Or
so we
everywhere?
did a Medium article, which just like
Mhm.
linked them all together, and then we had a thread on Twitter and LinkedIn.
What I was going to bring up, and by obviously this is terrific, is how do we make it so that undergrad students in material science are taught with these from the beginning, right? That should be the ultimate goal, because obviously it's easier. We can start with the grad students, right? Researchers, junior researchers that are actually generating the data. But the real impact would be to actually change how we do things from the get-go, right? Every undergrad student in the country, in the world, learning how to do this in their core courses. And that is a big challenge, because that you have to deal with old people, and then you do all this work. We've done this 20 years with NanoHub, right? You convince one professor, and then they stop teaching the class. Someone else teaches the class, and they don't do it. So you have to change standards. It's boring work, but this is, I think, how we can have a sustainable change. Is you need to change standards, change course descriptions, all stuff that is not super fun or fast to do.
I have an idea here, Ale. Maybe we should talk to ABET accreditors.
Yes, ABET, yeah.
And my department recently went through the accreditation, and the word fair starts to show up. So I'm not sure if this is like the beginning of the process, or they are already thinking about requiring, but I think this is very easy fix to the problem. I'm kind of practical person.
The thing is, ABET doesn't require you to do anything. ABET just
Right.
makes sure that whatever you say you do, you actually do.
I know, but
And
at
that you're
least,
improving.
yeah,
And
but
you're
at
improving.
least people will start thinking about it, because there was a bullet point that someone needs to think about, right? So I'm not sure. ABET.
So do you
Or
think that
provide a plugin for, I'm sorry.
So do you think that this will happen at some point, maybe not exactly by itself, but once the department start to hire younger generation of faculty who already data science oriented, so having one person in the department may be enough to initiate this transition?
Only if they're teaching that materials 101 class, right? So it's like we need to have a little companion module for Callister, whatever the most common undergrad Matt Sci book is, with some with a lab module, maybe a couple of them built on Olga, start like following Olga's example of the fair train that has everything there. It has the data, it has the codes, it has everything that's needed, and the faculty member doesn't have to know how to do it, just the TAs have to be able to implement it and grade it, right?
So I'll tell you a discouraging anecdote about Callister. We worked with him to incorporate NanoHub simulations in the book. And he was super excited. We worked with him for months until Wiley got involved, and they shut the whole thing down.
Really?
Because they have their online gallery, or whatever they call it. It's all animations that amount to nothing. No, they just didn't want to play with us. But he was very excited about adding new stuff to. Maybe someone, I was thinking before you mentioned Callister, that bring this PTSD. If you think about how we move, everyone uses an LMS that's pretty sophisticated, right? And no one teaches using chalkboards for the most part. That type of technology, I think when we change the technology, right? When we build a lab, and instead of having the old Instrum, we have a new instrument that automatically sends stuff and makes it available. That's, I think, how things will start changing.
So
Oh,
David,
so we could work with Silotech or one of the small desktop tensile testers for that particular module to incorporate something and have it propagate wherever that gets put in. That'll be a very slow process though, because although Duke is going to upgrade their material science lab for the first time in, I don't know, decades and decades soon. So we'll be the first in line.
so David,
But
you
this is
have a
what you need to
question?
do. ABET textbooks, it work with the equipment, right? It can be a researchy thing.
Sergey, I wanted to point out that in the Google Doc, John Allison has a question. I don't know if John wants to just unmute and ask it himself. If he doesn't in a second, I'll read it out.
Sure, I'm happy to. So one of the issues that we've been wrestling with is we find that, we've been trying to track citations in the Materials Commons to data, DOIs, and no one does that. You know, in our community, nobody is citing the data that they are reusing. Hopefully they're reusing it, but they've downloaded it, but they don't cite it. And one of the problems is that DataCite only tracks references, things that are in the reference list. So we've been noodling over and trying some experiments where we actually embed our reference to DOIs, data DOIs, in the reference list. So that's something we'll be trying and sort of tracking. But I'm wondering if anybody has, any of the panelists have any other ideas on this, or certainly establishing MaRDA best practices around this citation of data.
We at NanoHub, people can cite the tools, right? The tools have DOIs and you can track those and follow the citations to the tools. But it is a little different because both the data and the tools most of the time evolve, right? So the tools have versions and they keep being updated. And so there are a few things that with data, unless the data is never going to change, you know, it's not something that keeps growing. But imagine the materials project, right? The data, they keep adding data all the time. We do similar stuff with some of our data, and tools are the same where they keep evolving. So there are a few things that are slightly different that need to be thought out. Even the authors, right? New authors come in and they contribute. How do you give credit?
So I guess until the problem of interoperability between EndNote links, PaperPie links, Mendeley links, and the fact that Google Doc tends to kill half of them is solved, we are not going to cite the data more, right?
I'll point out an interesting anecdote. First, I'll agree with John that people need to cite data more frequently. People definitely use it, but they don't cite it in the ways that end up in the references. But actually, in the old days, for a while, Google was often accidentally indexing data sets as papers, and they're tracking citations very well. So if if we could somehow convince them to track those again, that would be amazing.
They dropped our tools too when they did that, and
yeah,
that was very frustrating. And good luck convincing Google to do something they don't want to do, right?
Yeah.
Because the material scientists care about that.
So would the right strategy to be somehow identify the publication of the data set and the scientific publication, so apply the same curation and review standards, throw in the workflow for the initial data analytics, and then basically the DOI for the data set and the paper becomes the same?
You could have, like, if we wanted to upend the whole publishing industry, and I wasn't here yesterday because I had a board meeting, so I missed anything that was said, but one could imagine for, you know, the publication process that you have technical reviewers that are reviewing, you know, some of the scientific aspects, and then maybe you have data reviewers that are reviewing the pipeline, the workflow, the codes, the accessibility, the data, so that one reviewer isn't expected to do both jobs. Like if that was inserted into the process, then it would be a way to ensure, or at least start you know, putting some structure around a data citation, and also would make the papers better and more reproducible in general.
I think Discover is already, data discovery is already doing it. I think, yeah,
Or
one
digital
of them.
discovery.
Digital discovery, yeah, they're already doing
Yeah.
it. Yeah.
I'm half joking here, but maybe when LLMs write our papers and LLM review our papers, these could be automated, okay? And I'm half joking because you can probably do a better job, right? We've shown that an LLM can actually write a better method section for a paper than the majority of humans. And so, and you know, they might be able to just cite everything, right? And make sure that the whatever workflow of data was used can be reproduced and the data could be cited.
Do chime in, Jake.
Yeah.
Yeah, no, I mean, I just wanted to mention, you know, this is something the journals are very actively working on. And I think that it, at least in my experience, it's exceedingly rare for people not to mention data sets that they work with. The key is getting it in the reference list. That's really the key, right? Versus these sort of parentheticals buried deep somewhere in the discussion that have URLs or various codes and so forth. And I think that, you know, more and more repositories are delivering DOIs, and you know, we certainly have pushed very hard to, you know, get the DOIs, you know, from people will just, you know, parenthetically paste in a DOI somewhere deep in the method section. And, you know, we're working to pull that straight into the reference list so that it's indexed, which is exactly, I think, what, you know, the issue here is, you know, not so much that it isn't mentioned, but that it isn't mentioned in a findable way that, you know, everybody's favorite indexer is going to then go and index it and count its use. And I think we're, you know, my hope is that we're very close to a threshold for making real progress on this, because there are now also vendors that are, you know, advertising these, you know, automated machine learning based protocols for finding, you know, sort of orphaned URLs or mentions of data sets and flagging them so that you can then move them to the reference list. So, you know, again, I'm at least for that particular issue, I'm hopeful that this is only a near-term problem that in the medium term we're going to be able to solve.
I guess secondary to that, we still need to convince the people who index the content that data sets are a thing, as opposed to like just tracking the papers.
Not my department,
that's not your job. Yeah.
I mean, the key thing here is obviously the ease of use, right? So, and the fact that when we buy something on Amazon, the things are done in such a way that it's super convenient because it's customer-oriented progress. When we are submitting papers to the journals, we are actually not customers. We are the interested parties. As the result, the convenience of the systems is well below what we can normally expect when we pay our own money for that. And it doesn't have to be this way. So, and the same thing obviously applies to a lot of other things. So the manual creation of conflict of interest documents with 800 names is also not something that should be done in 21st century. Nonetheless, that's how it is done. David.
I was going to say that there have been quite a few meetings, and one of the stakeholders that's working on solving this problem are those that issued the DOIs, right? And so the PID producers and DataCite, they're right now in journal publication. There are 4 places that if you have a DOI for your data set, it shows up in an acknowledgement or in the text or in the supplements, right? In a couple of places. And if that number can be reduced a little, they can sweep things out, and then they can track metrics on these things appropriately, which is part of their job. And then someone can have the conversation, because with more than us in the room, with an indexer. So the Web of Science or Google Scholar or whatever it is knows where they can get reliable information and not have to create it themselves. I think maybe you could then you have to sort of jump one river at a time, I think. And I think we are getting there. So.
Jane?
Hi, Sergei. Thank you. Some of you know of Dryad. It's a project that I was involved in when it launched. And one of the reasons it really was successful is the journals as stakeholders were brought together from the beginning and signed a joint data archiving policy And this is something that Linda Taylor and I are talking about in our MaRDA working group. And I think it's something that maybe MaRDA could really push forward, getting journals on board where they sign a joint data archiving policy. And what this means is when you get, if it's a journal that signed this, when the vanilla workflow, author submits article, it gets reviewed, it comes back, it's either major revisions, minor revisions, but it says, cite your data, this is how you should cite it, put it, in a repository, get your persistent identifier, and put that on your final draft before you submit it for publication. There are multiple workflows. Some of the workflows, people had data that was embargoed. Some of them have data that comes in as part of the review process, and you can allow for those. But getting the stakeholders and getting the journals on board really helped get this workflow going. And I think that's something MaRDA could do. And then if you start getting, journals on board, other journals want to join. And they like it because they pool their resources. The challenge is that Dryad was one repository. We can't have one repository in material science, and I can't even talk about that. I have no right because I'm not a material scientist. But this work that Cate's group is kicking off, and Cate, the stuff I want to share with you, is this list of trusted repositories where you get the persistent identifier could really, I think, help and have an impact. So just sharing some ideas.
So what incentive do you think the journals may be to engage in this direction? So for journals, ultimately the measure of performance is the revenue stream. So what would be the
They don't have to
them
be responsible for maintaining a repository, knowing that they're part of this initiative where there's a list of trusted repositories or other repositories, but they'll get more hits in their, of their resources.
It would be interesting to talk to the folks coming from the strategy roadmap development for publishers, because they have to deal with their own evil. So up to some point, increase of the number of publications was directly connecting to their revenue stream. At this point, the increase of the Sakana type of operations with the paper per $15 maybe just make them meaningless in the scientific sense. So I'm pretty sure that they're thinking about this type of concepts as well.
Thanks. Don't get too passionate. I'm muting.
Okay. Okay. So in the remaining 15 minutes, what about we explore the third direction?
Hey, we need a break, not 15 minutes.
I was given the schedule that I'm supposed to follow, which doesn't have a break. I don't know what you're talking about. Okay, so let's give it another 10 minutes for one more question and then have a 5-minute break. So training workforce. So we briefly touched it, but maybe it's a good idea to zoom on a little bit more. So how can we introduce the FAIR concepts or the extension of FAIR for the active experimentation and active learning into the curriculum? So is there anything in place now? So this is totally new, or this is something that has already started? And what has worked and what has been missing?
I can share my 2 cents. I think we can use the opportunity that there's real incentives to teach AI to students because the students demand it. No one demands to learn about FAIR data, right? They have no idea, but they do demand to know about AI. And you kind of need data, and you need FAIR data and AI-ready data to do AI. So this is an opportunity, I think, for us to push as we train the next generation of students. Well, you want to teach AI, you might as well think about what you do with the data, right? So you have meaningful data sets and you can share and people can benefit from them. So I do think it's an opportunity.
That's a good idea. So the programs that I have seen, at least at UT, that do put FAIR as one of the pillars along with applied computing and domain specialization. So that actually is a way forward.
So, Sergei, what they are saying is that your university is already teaching FAIR for material scientists, or?
There is an organization called KEX, College of Engineer something and Interdisciplinary Studies, which has been formed to provide the level of machine learning, which is halfway between the specific domain areas. So it's more general than just material science or just physics. But at the same time, it's much more domain-oriented than the general EECS type of courses. So, for example, the course that I'm teaching on the machine learning for materials and decision-making using Gaussian processes was not, they would be cross-slated with KEX. So there would be a special course developed, like a pair of courses of how do you use the web technologies, how you use the applied computing, and so on and so forth. So the idea is that you don't want to produce people who are narrow experts in running supercomputer. You want to produce a layer of people who know how to use these technologies, but on the level much deeper than it would be for classical domain scientists now, but at the same time have the vision of both their domain and computing. So this is kind of being done, kind of very interesting process, because you get to be in the room with people who understand the details of how supercomputer work, people who think about using generative AI in, for example, architecture or English language, and then the idea to come with a curriculum that builds the connection between the two. I learned a lot about the English literature that I've never knew before.
So I mentioned on our side the class we had at Northwestern that showed how to use all the different infrastructure pieces together. I think that was well received. Logan Ward actually had a class at UChicago, which was AI for materials. It had a module, a couple weeks of instruction on how to properly handle your data, your models, your code. And it was all very hands-on and through example. He posted that all on YouTube, so you can actually find it now. So, I think that's the other point, is meet people where they're at. So there's the classroom, but there's also YouTube where you can post these types of things to get people interested.
One thing I was thinking about doing is like creating a list of awesome FAIR, like all those resources that exist in different places. Yesterday I asked Marcus, who was like a panelist, like what resources he's using, and he gave me some. So I think there are like materials, teaching materials in different corners of the internet. Maybe creating a common list where people can look them up can be a nice way of lowering the barrier.
One of the ideas that surfaced before, but I think makes a lot of sense, is the idea to make the GitHub companions to the classical material science textbooks, kind of starting from Gaskell and so on. So it is very common in machine learning community, because very often somebody like Rasmussen will write the book on using Gaussian process using R, and then the community ports it to Python. So developing this type of materials and then using them as the part of the courses can lower the activation barrier for community to learn AI very significantly, because using the notebook is much easier than actually writing the notebook. David?
I was going to point out to Olga's comment that, for those who don't know, on GitHub, there are these repos called Awesome List, right? We need that. Well, let's make an awesome list, and then everybody can add things, because none of us know them all. That's for sure.
Oh, that's true.
I mean, they're a little silly. They get really big, but they also are places that you can go, what's the opposite of doom scrolling? Happy scrolling, to find things that you can go click on and go, I had no idea. It's cool.
Material scrolling.
Yeah, and Keo points that people have been doing these, so maybe we need to just link to other awesome lists, the list of lists, as we used to have.
So in the interest of the everyone on the call and future speakers, myself included, let's have a 5-minute break. Any last-minute statements?
I was just going to point out that one of the things on that prequel article that we did along the roadmap, one of the things was benchmark data sets. And so it's kind of along the lines of this list of where you could find data, but maybe it's specifically for big enough for machine learning or good enough for, maybe there could be a subset. This is stuff you can use for machine learning, and this is what you can use in your classes. And potentially people could be inspired by seeing that and say, well, I could make a benchmark data set and then get in and then go down the pathway of doing the right things to create such a benchmark data set.
Next year, we can have a whole session on benchmark data sets at the annual meeting if people get them ready.
There you go. That could be aspirational, right? That's right. Yeah, we could cover the gamut of a whole bunch of material system types and see how much data could be gathered. If anyone's interested in volunteering for the trusted repositories or sending a name, just a suggestion of someone you know that you think might be interested that I should contact, put their name in the Google Doc on page 7. I've got a little bullet list there for people to sign up.